All right, so I welcome you all once again. This channel is WASSCE TV. I'm your facilitator, Evans. Okay, so we are going to look at another question. In this question, it says a particle P of mass 1.2 kg is acted upon by forces F1, which is giving us 15 Newton in the direction of 90 degrees. F2 also giving us 20 Newton in the direction of 0 degrees. F3, 30 Newton in direction of 210 degrees. And the last force, which is F4, giving us K Newton in the direction of 8 degrees. If the acceleration of the particle is giving us 14 meter per second square in a direction of 240 degrees, find, and we are to correct to the nearest whole number, the force 4, so F4. So we are looking at F4. Now this one is also one of the WASSCE 2024 elective mathematics. So let's look at how we can do this. So first of all, we have been given these forces, and for such question, before you be able to solve it, we need to write these forces in a column vector form, and we also look at how we can resolve these forces. So let's look at how we can resolve these forces. So F1, we can resolve it since it is giving us 15 Newton and we have 90 degrees. So we can write 15 sine 90 degrees, also 15 cos 90 degrees. You can choose to bring the cos first, but if you want to use the cos first, then you should consider the angle, the quadrant formed there. But we don't want to waste time, so we can, if you are using sine first, then it is straightforward. Yes, when you use sine, when you use your calculator, the answer gives you straightforward. But if you want to begin with cos first, then you have to consider the quadrant. Okay, so this one, we are resolving the forces. So if we should resolve the first force, then we are getting, so if we use a calculator, then we are getting 15 and then 0 here. So we are writing them in column what form. Yes, so we are writing it in column form. So that is the first force. Now let's look at the second force, which is also giving us, so we have 20 sine 0 and then 20 cos 0. So if you resolve this one too, we are getting 0 and 20. Since sine 0 is 0, cos 0 gives us 1, and 1 times 20 is 20. All right. Okay. F3 is equal to, so F3 is also giving us 30 Newton, and then we have the direction as 210 degrees, 30 cos 210 degrees, which also gives negative 15, and we are getting here as what, negative negative 15 root 3, but I want to write the decimal form, so we are getting 25 0.981. So I run out to 3 decimal places. All right. Now let's also look at force number 4. And in this case, looking at the question, this one we were not given the exact number here, but that is what we are looking for. So we have K here, we have what? A here. So these represent what? The figures, but we don't know the figures yet. So we also need to resolve that. So this one, if we are to resolve this one as well, then we have K sine. Then what is the angle? What is the direction? The direction given is what? A degrees. So I'll put my A degrees here, and then K cos A degrees. Good. So if you resolve this, this is what we are going to get. All right. Now, since we have the acceleration also given as this, then we also need to resolve the acceleration as well, because this one we have been given this and another hot thing here. We have a direction here. So once there's a direction here and we are resolving all the forces, then we should also resolve for the acceleration. So if we resolve the acceleration, then we have A is equal to, but remember this A you see here, it is not this A we are talking about. This is what the degree, but this A we are talking about the acceleration. Have you gotten that? Good. So this one too, if we resolve, then we have 14 sine 240 degrees, and then 14 cos 240 degrees, which will also give us so this one too, we can get negative 7 root 3, but I want decimal, so we are getting negative 12.124 to 3 decimal places, and we have here as negative 7. Good. So we have also resolved the acceleration here. All right. Good. So once we have resolved, don't forget to bring this. So we have this here, that's Newton, because it is a force. And for acceleration too, we are getting what? Meter per second square. Good. So that it will tell you that this is what? Acceleration, and this is also what? Forces. Have you gotten? They are forces. That's why we are representing it as what? Newton. All right. Good. Now, since we have these forces here, now I think we need to, because the forces are how many? 1, 2, 3, 4. So what we'll do is we are going to find the resultant force. Have you gotten it? We are going to find the resultant force. And in finding the resultant force, what do? We only have to sum all the forces. Then we are getting what? The resultant force. So if we are getting the resultant force, then we can see that the resultant force, which is giving us F1 plus F2 plus F3 plus F4. So we are going to add all this so that we get the resultant what? Force. So the resultant force, which is equal to so the first force, we resolve it and got what? 15 and 0 here, plus then F2 we got 0, 20, F3 we got negative 15 and negative 25.981. That for F4 we had K sine A degrees and K cos A degrees. Good. So let's add this. I think we can add this then. So if we are adding, then what are we getting? So if we add this and this, then we are getting 0 here, and negative 5.981 plus k sine a degrees and then k cos a degrees. All right, good. So this is the resultant force. Have we gotten that? All right, because we don't have real values here, that's why we are getting this. Okay, because looking at the question, this is what we are looking for, and that is the F4. All right, good. Now, once we have the resultant force, that's the F, then, and we also have the acceleration. And in the question, we have also been given what? Mass as what? 1.2 kg. So once we have mass and then we have force and we also have acceleration, then something should come in your mind. We are going to use a specific formula here. So this one, what you should be thinking of is we are going to look at what? Newton's second law. Yes, so here, once we have mass, we have force, and then we have acceleration, then Newton's second law comes in mind. So that is what we are going to use here. So according to Newton's second law, um, forces or resultant force is given as, so in Newton's second law, resultant force is equal to what? Mass times what? Acceleration. Good. So if you remember this in Newton's second law, then we can only do what? Substitution, because we have already calculated for what? Resultant force, and then we know our mass as 1.2 kg, and also we have also worked out for our what? Our acceleration. So we can quickly do this. So we only do substitution. So for F, we got this. So we put the whole there. We put the whole there. It's equal to. So we know mass as what? 1.2. And looking at it, this is what the product. So the product of mass and acceleration gives us what? The resultant what? Force. Have we gotten? It gives us the force. That is what Newton's second law states. Okay, so since we are finding the product, then I will only write my acceleration, which is giving us negative 12.124 and then negative 7, all in column form. Okay, all right. So let me repeat this. Okay. Good. So let's multiply this. Let's multiply this. So 1.2 times all this. So we are getting negative 14.5488, and then the down one here we are getting negative 8.4. Good. So this is what we are getting. All right. Okay. So let's continue. Let's continue. So let me turn my page and then work it on the next page. All right. So once we have this, then we can group items. So we can write this here. So we can write this here. That is our k sine a, and then k cos a degrees should be equal to because we are grouping items, it should be All right, so if you group like terms, so we are having this. Therefore, we can have this as so we have -1 for 14.5488 and -2.419. Good. So it means that we have to equate each of them to the other side. So once we have this, then we can write k sine a degrees is equal to -14.5488. So we can call this equation 1. And then we have k cos a degrees is equal to -2.419. Then we can also call this equation 2. Okay, so we need to solve these equations. So once we have this, then we can say that from equation 2, we can say that k is equal to -2.419 all divided by cos a degrees. So once we have this, we can also call this equation 3. So once we have this equation, then we can substitute equation 3 into equation 1. So if we are to put equation 3 into what? Equation 1. Okay, so it means wherever we see k, then we put this one here. So once we have equation 1, then we can write this as -2.419 dot sine a degrees divided by cos a degrees, which is equal to -14.5488. Good. So we can divide both sides by -2.419. So we can write this as sine a degrees divided by cos a degrees, which is equal to 14.5488 all divided by 2.419. Good. But note that tan a degrees is the same as sine a degrees over cos a degrees. So this is one of the trig identities. So we are saying that whenever you have tan, this is supposed to be this. So this time we are going to write this here. So we have tan a degrees is equal to 14.5488 all divided by 2.419. So once we have this, then we can take a tan inverse of both sides. So we can have this as a degrees is equal to tan inverse of 14.5488 all divided by 2.419. Okay, so we have a degrees as, so when you take this, then you are getting if you use your calculator, then we are getting 80.55992474. But remember, the question says we should leave our answer in what? To the nearest whole number. So if you are leaving our answer to the nearest whole number, then this is 80. If you run up, then we are getting what? A degrees is equal to what? 81 degrees. So this is the angle. Now once we have calculated for A, then we need to find what? K. So once this is done here, then looking for K becomes easy. We only need to substitute A into any of the equations. So this one I will choose equation 3 because that one gives me the K direct. So I will choose equation 3. I only put 81 here and then solve for it and I'm gone. So here my K is equal to negative 2.419 divided by cos 81 degrees. Good. So if you use your calculator, then we are getting negative 15.46334, and this one also says we should leave our answer in the nearest whole number. Therefore our K becomes negative 15 Newton. Good. So once we have K as negative 15 Newton, we can then conclude that the force F4. So we can say that therefore the force F4 is given by negative 15 Newton. Negative 15 Newton, and since we have 81, then we can write 081 degrees. So this gives us what? F4. So this answers the whole question. So see you next time. Thank you.